A common logarithm is a logarithm with base 10. You can write a common logarithm, log base 10 of x, simply as log of x, without showing the 10. So in general, if you see a log without a base expressed, assume that the base is 10, and that the logarithm is the common logarithm. Many measurements of physical phenomena have such a wide range of values that the reported measurements are logarithms, exponents, of the values, not the values themselves. When you use the logarithm of a quantity instead of the quantity, you're using a logarithmic scale. For example, a seismograph measures the magnitude of earthquakes using a logarithmic scale. The decibel scale is used to measure the power or intensity of sound. In chemistry, the pH scale is used to measure the acidity of a substance. Apparent magnitude is used to measure the brightness of objects in space, as seen from Earth, using a logarithmic scale. The Richter scale is a logarithmic scale. It gives logarithmic measurements of earthquake magnitude. Take note of the image. The Richter scale, shown here, a magnitude 1 earthquake on the Richter scale represents an energy level being multiplied by 30 to the first power. A magnitude 2 earthquake, the energy level is multiplied by 30 squared, or 900. Note that's 30 times as intense as a magnitude 1 earthquake. A magnitude 3 earthquake, well, that is E times 30 cubed, which is 30 times the magnitude of a magnitude 2 earthquake on the Richter scale, and so on. So each time the magnitude increases by 1, the energy released is actually multiplied by 30. Problem 3. Using a logarithmic scale. In December 2004, an earthquake with magnitude 9.3 on the Richter scale hit off the northwest coast of Sumatra. The diagram shows the magnitude of an earthquake that hit Sumatra in March 2005. The formula, log of I sub 1 over I sub 2, equals capital M sub 1 minus capital M sub 2, compares the intensity levels of earthquakes, where I is the intensity level determined by a seismograph, and capital M is the magnitude on a Richter scale. How many times more intense was the December earthquake than the March earthquake? We'll use the formula log of I sub 1 over I sub 2 equals M sub 1 minus M sub 2. We'll substitute the values. M sub 1 equals 9.3 and M sub 2 equals 8.7, our Richter scale magnitudes for the earthquakes. So log of I sub 1 over I sub 2 equals 9.3 minus 8.7, and that's 0.6. Then we'll apply the definition of common logarithm and rewrite the equation as I sub 1 over I sub 2 equals 10 raised to the 0.6 power, and we'll use a calculator to evaluate and find this is approximately equal to 4. So we can state the December earthquake was about 4 times as strong as the one in March. Your turn. In 1995, an earthquake in Mexico registered 8.0 on the Richter scale. In 2001, an earthquake of magnitude 6.8 shook Washington state. Approximately how many times more intense was the 1995 earthquake than the 2001 earthquake? Use the formula given in problem 3.